Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello friends. So we are learning schema design since last two lectures, and this lecture is continuation to that. That is how you find attribute closures. So attribute closure is completely based on functional dependency. So the real-time example of functional dependency is attribute closure. So what is an attribute closure? Deriving the closest set of attributes of a given determinant is the concept of attribute closure. So the basics of attribute closure is a functional dependency, and the attribute closure further provides and helpful in order to derive key derivation. So as I told you, in order to compute the attribute closures, there is a requirement of functional dependency. Valid functional dependency is required. So we start the lecture with what is the application of real-time application of functional dependency. So the real-time application of functional dependency is attribute closure only. So this is an idea. So functional dependency is going to provide the concept of attribute closures. So what is attribute closure? An attribute closure is nothing but deriving closest set of attributes of a given attribute or of a given determinant. Okay? Then one more important point is that attribute closure is computed by taking this signal. So using this sign, you can able to identify that we are computing the closures of a given determinant, right? Once again, a small recap. So the application of functional dependency is nothing but attribute closure. The concept of attribute closure is nothing but derivation of closest set of attributes of a given determinant. So while using attribute closures, again we are going to use the concept of functional dependency inference rules. So therefore, Armstrong axioms are being used to derive attribute closures. So we know what are the Armstrong axioms are there. The Armstrong axioms, one side we have discussed reflexivity and we have discussed transitivity and we have used augmentation and we have used union rule and we have used union at decomposition and we have used accumulation and we have also used pseudo transitivity. So again, these are all the rules are being used in order to compute or calculate attribute closures. So what is an attribute closure? An attribute closure is nothing but derive a closest set of attributes of a given attribute or of a given determinant. This is one of the real-time application of functional dependency. So where will you use the functional dependency? We use the functional dependency in order to derive the attribute closures. While calculating the attribute closures, we are going to implement all the properties of Armstrong axioms. As we know, these are all nothing but Armstrong axioms only. Right? Copy now. So I hope so. You copied. Now we will see how attribute closure is being computed or calculated. So what is the requirement of attribute closure? The requirement of attribute closure is valid non-trivial functional dependencies or valid semi-non-trivial functional dependencies, right? Or by a given trivial FDs also you can able to calculate attribute closures. Okay. So therefore I am giving you valid functional dependencies now. This is the question. So what is the question? Some functional dependencies are given A to B, B to C and BC to D. He is asking find the closure of AE. So he is asking you to compute closure of AE. So I am computing AE closure. When you are computing AE closure, you see that use the reflection property. So what is the reflection property? Whatever is there in the left hand side, I can write at the right hand side. Right. So therefore, I am taking AE, so I am also taking AE into the consideration. Now, you map using given functional dependencies such that what you can additionally write in this closure set. Once again, map the given functional dependencies and write the new derived productions in this particular list. How? Just Be attentive and follow me. I have A with me. If you know A, what I can write? B I can get. So I can post B here. Get my point? I know the determinant value A and I can get which value? B value. So write the B value over there. I know B value, I can get which combination? C I can get. And I know BC combination now. So if I know BC combination, what can I get? D I can get. So this is how you can easily compute attribute closures. See how simple it is to find the attribute closures. Now, what is AE closure? AE closure is nothing but A, B, C, D, E. This is what is the meaning of AE closure, right? And we will look at into another example. So this time I am saying A gives C and AC gives D and CD gives you E. He is asking find a closure of A. Now you tell me what I said the rule number one. The rule number one is whatever attribute you have with you, you write that attribute in the list using the concept of reflection. So since I have A with me, so I note it down in the list A. Now you map the further productions which are based on what? A. So if I know A, what can I get? C I can write. I have A combination or C combination, or I can use both the combinations AC together. So if I know AC, what I can get? D I can derive. Now you can use A individually, C individually, D individually, or AC or AD or CD or ACD together you can use in order to further mapping of the attributes. So since CD I know, I can get which value? E value. So what not? Anything, everything I got it. So therefore the closure of A is nothing but what? ACDE. So what is the meaning of a closure? The meaning of a closure is by using these dependencies, if I know AE value, I can get AE BCD, which means AE will give you A, AE will give you E, AE gives me B, and AE also gives me C and D. Now in this case, if I know alone A value, using these dependencies, A can map to A can map to C, and A can map to D, and A can map to E. These are the possible available functional dependencies after calculation of attribute closures. Okay. Now let us do one more example. Don't write unless I say. So let me complete right hand side part also. If I am giving you an example over here, that is, I am taking AB tends to C and BC tends to D and E tends to F. He is asking find a BE closure. Again same rules you follow. Solution, you start doing BE closure. If you know BE, what can I write? BE I can write. What additional you can write now? Tell me. Is there any combination of B at the LHS? No. Is there any combination with E at the LHS? Yes. So I know E value. I can get which value? F value. Now any other can I map? If you want to map C, what is required? AB is required. So AB combination is there with you. You want to write D, so what is required? BC is required. BC combination is not there with you. So That's enough. This is only your closure of B using these given functional dependencies. And the last example, I am saying A gives BC and BC gives D and CD gives E. He is asking find BA closure. So what is the answer? BA closure. The solution, you start do BA. So I have BA with me. Now what can you get? I know B. Can you get anything else? No. I know A value. Can you get anything else? Yes. I can get. If I know A, I can get what? BC. Already B is present. You write the C value. Now I have BC combination with me. If you know BC combination, I can get D. Now you got a CD combination. CD will give you what? E. So this is the BA closure, which means if I know BA, using these dependencies, BA can give B and BA can give A, BA can give C and BA can give D, BA can also give E. This is how you can compute attribute closures. Very important attribute closures. Why? This was asked in the previous gate bit in the year of 2006. And this is very important. Why? In order to derive the next our topic, key derivation like candidate key and super key. So right now you're supposed to understand carefully and copy now. Okay students, I hope so you have got copied. Now you also confident in proving attribute closures. So what attribute closure required? Attribute closure required valid functional dependencies using the Armstrong axioms rules. Just post the values in the given set. So the concept of attribute closure is nothing but derivation of closest set of attributes of a given determinant or of asked attribute closures. Now you open your classroom workbook, question number 6, which is under attribute closure concept. So we are solving question number 6 of your classroom workbook. The question was asked like this. So this is the question number 6 of your classroom workbook. R of A, B, C, D, E, F, and some functional dependencies are giving. Now, who would like to find AB closure? So this is the question number 6. Now you tell me the solution will start with AB closure. So what is AB closure? Can you guess what to write? And the step number 1, use the reflection. Whatever is there in the set, you can write in the set AB. Now map the attributes based on Armstrong axioms. I can use A individually or B individually, or I can use AB combined together, right? Now, if I know A value, I can get what? C and E I can get. So, since I come to know the value of B, if I know B, I could get what? D value. Since I know the value of C, I could get what? A and D. So since I have the combination of B and D, what can I get? EF. So what is the answer? Eliminate the redundant attributes of right hand side. The answer is A, B, C, D, E, F. So what is the option? None is your answer. Okay. Now you also look at into question number 7, which is a part of attribute closures. So what he is asking? So some R is given and some valid dependencies are given, and he asks you to find which closure? AC closure. So yeah. Now you tell me guys how to solve this problem. So he is asked you to find which closure? AC closure. Very easy to prove attribute closures like FDs only. So whatever learned in the classroom, all our shortcut tricks as much as possible we would like to give you. So you try to utilize these shortcuts and analyze the answers in easy and quick manner. So what is AC closure? So use the rule number 1. What is the rule number 1? Whatever attribute set you have, that you put it in the right hand side. Now that's it. You map the rest of the attributes. I have the A combination. What can I map? B I can write. And I have BC combination. I have BC combination. What can I write? DE I can write. Don't see that they are not in order. So you can write, if you have any combination, I can able to map swapping. It may be ABCDE, it may be ACBDE, it may be ACBDC, whatever it may be. Okay, order is not important. See that that attribute is there with you or not. So now, in order to get G, what is the combination you required? AEG. Do you have AEG combination? No. I have A and E combination, but G is not there. So there ends, you have to stop your calculation of attribute closure. So what is the answer of AC closure? The answer of AC closure is, what is that? A, B, C, D. I hope so you got it how to solve the problems. So we do some other problems based on your classroom workbook. First copy them. Okay guys, I hope so. You copied and you got it how to do the problems. Now let us do question number 8, which is a part of attribute closure. So what is the question number 8? Same. R is given with A, B, C, D, E, and some dependencies are given. He is asking find AB closure. So now you see. So he is asking AB closure. So the solution start with here. So use the rule number 1. Use the reflection. Write the things which are there with you. Now map them. if I know A value, what can I get? BC. B is already present. So E combination is not there with me, so I can't write this CF combination. We will move to next production. B tends to E. I have a B combination with me. So B, I can able to use E there. And in order to get ED combination, I do not have CD combination with me. So, but I can get one more combination. What is that? Since I got E combination here, so E can get what? C and F. C is already present, so I can write F. That's it. So AB closure is nothing than A, B, C, E, F. So the option is what? C. Now let us do question number 9 of your classroom workbook, which is a part of attribute closure. So the question is like this. He is asking find AC closure. So the solution, this time you know how to do it. AC closure, tell me what to do. First step, AC. Now what is to do? Second step, map the productions by using the combinations you have in the right hand side set. So since I know A value, I could get B. So I know BC value, so I could get DE. So anything could you get? So you can't get G combination unless and until you have AEF combination. I have AE combination. I do not have the complete combination of AEF. So unless I know AEF combination, I cannot get G. So your answer is what? AC closure will be ACBDE. So what is the option which is correct? A, B, C, D, E. So option B is correct. Okay. This is how the question number 8 and question number 9, which is a part of attribute closure of classroom workbook. This is how to solve. So you get copy. We'll do question number 10 based on attribute closure, which is given in the year of GATE 2016. Sorry, GATE 2006 of IIT Kharagpur. So get it copy. Yeah. Okay, students. Now we will look at into another question. Question number 10, based on attribute closure, which was your previous gate bit of IIT Kharagpur, given in the year of 2006. It is slightly tricky than the previous models, whatever we learned so far as per attribute closure concern. So observe the question carefully. Question number 10 of classroom workbook, which is a part of attribute closure. So as I told you, this is one of the bit of 2006, and the question was like this. He is asking, what is false? This is the last option D. Yeah, he is asking what is wrong in that. So let us analyze. These are the functional dependencies are given, and these are the closures he has given. You see that this closure would you able to get or not? There are multiple answers in that. So let us prove which one is correct, which one is not correct. So I am checking with option A. So what is option A? CF closure. What is there with you? Tell me. What is there with you? C and F is with us. Now math. I do not have AV combination to write CD. I do not have AF combination to write D. I do not have DE combination to get F. I have C combination and I have F combination. So C will derive G, F will derive E. So I can get them. Now since you have a G combination with you, what I can derive, A also I can derive. Once go back. So do you have AB combination to get CD? So AB combination is not there. Do you have AF combination to get D? AF combination, yes, we have AF combination. So I can write what? D. Now do you have DE combination to get F? You need not check that because F is already present. And once again you go back, do we get any other attributes? To get CD, what is required? AB. Do you have AB combination? No. So that's it. The CF closure is A, C, D, E, F, G. You see now? A and C and D and E and F and G. So this is true because we get A combination and we also get C combination and we also get D combination and we also get E combination and F combination and G combination. So it is true. Let us check option B. So option B is a BG closure. Now BG with U. Now again remap them. So B, anything will you get? Not at all, because B is not available at the left hand side. So but G is having with you. Since you have the G combination, I could get what? A. Now you see, you got a good combination, A and B. If you know AB combination, I can get what? CD combination. So you write CD combination. Anything will you get? So already D is present, you need not check this condition. And F I want. So you want F, what is required? A DE combination. You don't have DE combination, so you can't write F right now. G is already present with us, need not check. You want E combination, what is required? F is required. We don't have F with us, so you can't get it. So G combination will give you A is also there with me. So therefore, this is the closure which is restricted by BG. So what is answer? You have A combination, you have B combination, and C combination, and D combination, and G combination. So therefore, this is also what? True. Now let us see option C. So what is option C? AF closure. So I have AF with me. Okay, what will you get? By knowing AF, what will you get? D you can get. Anything will you get? If you know F, what will you get? E you can get. Okay, anything will you get? You have DE combination, so I can get F. Otherwise, let us check. You want CD, what is required? AB. AB is not there with you. So D is already present, you need not check this combination. And F you want, already it is present, you need not check this condition. You want G, what is required? C is required. C is not there with you, so you can't get G value. I have F with me, I can write E combination, I got E. So nothing else. Anything else? Nothing else. So this is the closure of AF. But here given AF closure is ACDEFG. But AF closure is what? AFDE. Once again, recalculate. I have AF with me. Before putting this is answer, let us recheck. So AF will give me a D. Since I have a F, I can get E combination. Now you identify, will you get any other combination as far as this answer concerned? So I have A, I have F, I have, and D, I have, E, I have. He is asking about C and G. To get a C, what is required? AB is required. You don't have AB combination. To get G, what is required? C combination. We don't have C combination. Hence, I can say this is a what? False. Don't stop. We will check option D also. Because there may be a chance of multiple answers. So what is option D? We would like to find AB closure. So AB is there with me. So if you know AB, what can you get? CD I can get. Now this is completed. D I have, I need not check this combination. F I want. You want F, which combination you required? DE combination. But D is there, E combination is not there, so you can't use right now this. And G you want. You want G means what will you have? C. So C is there with me. I can get a G combination. And E you want. E you want means which combination you require? F combination. And G will give you which combination? A is already present to me. Let us recheck once again. AB will give me CD. And D is already present. You need not check this condition. F you want, there is a need of DE. D is there, but E is not there. You can't get. G is already present. and E, you want there is a combination of F is not there, and that's it. So your answer is what? A, B, C, D, F, G. But what is the answer you get? A, B, C, D, G. So therefore, this is also what? False. So what are false? C is a false and D is a false. This is how you have to do the concept of attribute closures. Right? Copy. Okay guys, I hope so you completed or copy it. Now the idea behind attribute closure is nothing but you see the LHS set and try to derive the RHS set. Okay, so we will learn in the next session how to compute key derivation. Why? The basics of attribute closure is derivation of the key only. So functional dependency application is attribute closure application is a derivation of the keys. So we will see the next session how to calculate the keys and all. Thank you very much for watching the session.